Hello everyone, welcome today. So today we'll be talking about the energy module of the Year 11 syllabus, and in particular we'll be talking about carbon and its allotropes. So carbon is our topic for today's lesson, and so why do we want to study carbon? What is it useful for? And how does it affect us? So when we talk about carbon, it's important for us because we're what we call carbon-based organisms. So all of our body is made of some kind of carbon compound, and that's why carbon is very useful or very important to talk about in the context of chemistry. So we'll talk now about carbon compounds. So because carbon has 4 valence electrons, so when you think back to the periodic table, it's in group 4, so it has 4 valence electrons. It means that it can combine with many non-metallic elements to form rings and chains. So we can form chains of carbon compounds. So one would be something like octane, so the petrol in your car would be a long chain of carbon. It can form rings like benzene, a carcinogen, but also used in other things. And so we get lots of different things that can happen with carbon because of those 4 valence electrons. And what it can do is it can allow carbon to form millions of different compounds. So if you think about all of the compounds in our body, most of those have carbon in them, and there's easily a million different things going on in our body. Then you think about all the fuels and things that we have for planes and cars and all sorts of machinery, oil, and then that's another million compounds. So we're already at 2 million types of compounds, so we can just keep going from there. And remembering that it's due to those 4 valence electrons. Additionally, carbon is found in organic and inorganic compounds. So organic meaning just carbon to carbon type compounds. So these kind of compounds, these rings or chains. But it can also be found in inorganic compounds. And remembering, I think when we talk about oxygen bonding with something else, a metal, we say it's an oxide. So we can also form carbides as well. Not as common as these, mainly because there's so many of these, but they are found in industry and other places. So what is the carbon atom, and how do we sort of define it? Well, it's atomic number 6. Okay, so if we look at our little periodic table diagram, it's right over there in group 4, and its atomic number is 6. Now again, found in group 4, which is to be expected. And the most common isotope has a mass of 12. So when we look at this diagram, it's got 2 electrons in the innermost shell, as you can see, so 1, 2. And then in the outermost shell, you've got 1, 2, 3, 4. So you're totaling 6. So in this case, 6. The atom contains 6 protons and 6 neutrons. So as you can see, if you count them, there'll be 6 of each. And so 12 is the most common mass. Okay, so there are other isotopes that have different numbers of neutrons, but we won't consider them just for now. So 6 electrons are distributed around the nucleus. So 2 in the first shell, as I mentioned, and 4 in the outermost shell. So again, we're looking at the innermost shell is 2, outermost shell is 4. So we have 4 valence electrons, but 6 electrons in total. So the shells are K2 and L4. And the subshell structure is this. So this is sort of beyond the scope of your Year 11 chemistry, but just for completeness, we'll put it in, simply because some people like to ask about these things, so we like to give them the answers. So remembering 2 electrons in the inner shell, 4 electrons in the valence shell for sharing to gain the stable octet. So those 4 electrons either need to be given away, or 4 electrons need to be taken in, or we need to share another 4 electrons so that our little carbon atom here is nice and stable because of that octet structure. So bonding of valence electrons. So we tend to find mostly covalent bonding with carbon, and very rarely we see sort of ionic type bonding. So here we have carbon dioxide, a very well-known gas, possibly the cause of global warming in our planet. And so we've got O double bonded to carbon and then double bonded to another oxygen. So you can see here that there are 2, it's sharing 2 electrons, and on this side it's sharing 2 as well. That's why we have a double bond. So each atom is sharing 2 electrons with its neighboring atom. So if you count, there's 4 here, 4 here, so the total is 8. So if you look at the dot structure now, so remembering that these 2 bonds count for 4 electrons, each bond counting for 2. So we have, if we ignore this side, we have 1, 2, 3, 4, and then another 4. Then if we ignore this side, we have 1, 2, 3, 4, and another 4 here. And if we ignore the 2 oxygens, we have 4 and 4. So everyone's happy with the full 8. Now if we look at methane, a very similar, well not very similar, but the same, only covalent bonding. And you have single bonds now, so only sharing 2 electrons between each hydrogen and carbon. And if we look at it again, we have, if we ignore just say all of this hydrogen has 2 electrons, which means that its outermost shell is full. And if we look at just the carbon without all the H's, it has 8 around it as well. So this is how it generally bonds together to form lots of compounds that we can use. So this wraps up today's topic on just carbon and what it can be used for and how it bonds. And so we've talked about why carbon is useful, we've talked about how it bonds, what it is, and all of its properties. So next lesson we'll talk about the carbon and its allotropes, and we'll define what an allotrope is in that lesson. So we'll move on to the questions. So question 1, which of the following is not correct about carbon? So carbon has 4 valence electrons. Okay? We know this to be true, so this is not the correct answer. Carbon can form 4 bonds with other atoms, again, because it has 4 valence electrons. We know that this is also true, so it's not correct. Electron configuration is 2 in the first shell and 4 in the second shell. Again, we know this is true because its atomic number is 6. So this is not the correct answer. So what we have here is the last one, which is the correct answer. Carbon can form a double or triple bond. It depends on what it is, but carbon itself won't be able to form a triple bond or double bond unless we know what the other chemical is that it's bonding to. So of course this is the incorrect answer. So which group does carbon belong to? So we look at our periodic table and we find carbon, so it's pretty obvious what the answer is when we look at that diagram. And the answer is group D. Is answer D, which is group 4. Okay. So how many protons in the nucleus of carbon? So again, we look at our periodic table and we ask ourselves, well, what is the atomic number? And the atomic number tells us the number of protons. And so from this, we can see instantly what it is. And the answer is 6. Okay. So we'll draw a diagram to represent the carbon atom. So we start with remembering 6 protons. So there's 6 protons there, the plus signs. Then we add 6 neutrons, remembering that we have equal numbers in this case. And then we need the equal number of electrons. So that is also 6. So we start with 2 in the inner shell, and that's full now. And then then we add another 4, and then we have our carbon atom. Is that clear? So if that is okay, we'll move to the next question, which is draw the Lewis dot structure of methane. So we saw methane in one of the earlier parts of this lesson, and that's what it looks like. Single carbon in the middle, covalently bonded to 4 carbons around the outside. Now draw the structural formula for carbon dioxide. And again, we saw that in an earlier part of the lesson, and that's just O double bonded to C, which is then double bonded to another O. So from this diagram. Okay? And the last question is, explain why carbon can form so many different compounds. And for those who have seen many of my other lessons, we will focus on what the verb is trying to tell us, and that is the cause and the effect. So what is the cause of the fact that what is the cause of carbon forming so many compounds, and what is the effect? So carbon has 4 valence electrons, and therefore it can form up to 4 covalent bonds in order to achieve that stability, right? So it can form at most 4 bonds, which helps to build other chemicals. Now, carbon can form bonds with non-metallic elements, as well as other carbons, as well as non-metallic elements, which means that it can bond to nearly everything in the periodic table. So you get a large range of molecules that you can form. Furthermore, carbon can form long chains or rings, and that increases the number of ways that we can bond carbon together, because a ring will have different properties to, say, a chain of the same number of carbons. Okay, so that wraps up today's lesson on carbon. And so we've talked about what carbon is and why is it helpful to us, and the number of different compounds that carbon can form and why that happens. So in the next lesson, we'll talk about carbon and its allotropes, and I'll explain hopefully what an allotrope is, and then we'll talk about how those allotropes affect or are used in today's society. So I look forward to seeing you at the next lesson.